the displacement of an object can be positive or negative, depending upon the direction where the object is moving. Now let's see examples where we can have a positive displacement and where we have a negative displacement. These are the two cases. In this case, there is an object which was initially at 10-meter position, at a distance of 10 meters from the origin, and the final position is 80 centimeters. This is the final position, which is 80 centimeters. So, as we know that the displacement of the object is expressed by the difference between the final position and initial position. So, as you can see here, the final position is 8 centimeters minus its initial position is 10 centimeters. Then this will be 80 minus 10 is 70 centimeters. Positive. But in this case, this positive could mean that the object is going to the right, because normally from our mathematics background we know that this is positive x-axis, this is minus x-axis, this is positive y-axis, and this is minus y-axis. So when you say this positive, it means that the object is going to the right. Right, east are considered to be positive axes, and left and west are going to be considered to be as negative. So in this case, we get a positive displacement. This is what? Positive displacement. Let's see a case where we have a negative displacement. In this case, the object is going backward from an initial position of 20 centimeters. This is the initial position, 20 centimeters, and the final position, this is 80, this initial position 80, 8 centimeters, because it's going from the left side, from the right to the left, and the final position is 20 centimeters. So in this case, the displacement is given by the final position minus the initial position. So the final or destination point is, as you can see, it's 20 centimeters minus the initial position is 8 centimeters, and that will be, we are subtracting big number from small number, and we get minus 60 centimeters. So this minus shows that the object is moving backward or to the left side. Now the next point that you have to know is the meaning of average velocity. What does it mean? What is the meaning of average velocity of the object? So average velocity can be defined as different ways, but normally this is defined as the ratio of total displacement to total time interval. This is defined as total displacement divided by total time interval. The total time taken to cover that distance. So average velocity is defined as the ratio of total displacement to total time. That is, average velocity is abbreviated as VAV, which is given by the total displacement or the total displacement change in x divided by change in time. That's how we define average velocity. So when you say change in x, we mean that the difference between the final position minus initial position divided by the time interval, duration of time, or delta t. And here what you have to do is, what is the SI unit of average velocity? As you can see from the formula, the unit of average velocity is given by the ratio of the SI unit of displacement to the SI unit of time. And we know that the SI unit of displacement is meter and that of time is second. So the SI unit of average velocity is meter per second. This is its SI unit. But we have also other units, like the other units we can also measure average velocity by kilometer per hour, kilometer per minute, or meter per minute, or kilometer per minute, or mile per hour, etc. We have different units of average velocity. And here velocity can be interpreted graphically. This is very important. Like a graph will be given, so we can derive or we can calculate the velocity of the object from the given graph. Let's see, for example, in some graphs we have different graphs. Let's see the common type graph. That is time, which is measured in second, and the displacement, which is measured in meter. Or you can call it change in x. They are all the same. So when you put the SCT graph of uniform motion, it depends upon the type of motion that you have. For this particular case, let's see a case where the velocity of the object is the same, or constant motion. So for the motion with constant velocity, that is called a uniform motion. That's motion with constant speed. A motion with the same speed throughout the motion is called uniform motion. So for this case, when you draw the SCT graph of uniform motion, we will get a straight line. This is the SCT graph of uniform motion. So for this case, when you calculate the slope of this line, the slope of this line is the same as the velocity or the speed of the object. V is the object. This is very important. So the slope of SCT graph of uniform motion is the same as the speed of the object. Or we can also express as when the motion is uniformly accelerated motion, that is when you have time in second and speed in meter per second. For a uniformly accelerated motion, means a motion where the speed changes but the acceleration remains constant. In that case, we will have a straight line graph. This is VT graph, speed time graph or velocity time graph. In this case, when you calculate the speed of this object, the slope of this line is the same as the acceleration of the object. The speed time graph of uniformly accelerated motion is the same as the acceleration of the object. The slope of this line, calculating the slope of this line means calculating the acceleration of the object. So we can also express velocity of the object graphically. Actually, these are simple examples. We will see it in detail. Let's see sample examples, how to find the average velocity of the object. Let's see examples. The first example is during a race on a level ground, Andra runs with an average velocity of 6.02 meters per second. To the east, because we are talking about velocity, we need to have direction. What is Andra's displacement after 137 seconds? So it will be better if you list out the given quantities first. What are the given quantities? We know that the average velocity is given, that is 6.02 meters per second, and time is also given, that's 137 seconds. So what's asked is, we are asked to find what is Andra's displacement, that is displacement of Andra. So let's solve it. Let's solve the last step. So whenever you are solving physics problems, it will be better for you if you list out the given quantities. Pick out the given quantities from the question. So the next step is you start with writing the formula. Write the formula. That is the ratio of average, the ratio of total displacement or change displacement divided by change in time. This is the same as average velocity of the object. So average velocity of the object is given by the ratio of total displacement by total time, or time interval. So we want to find this one. So what we do is we just put this over one crisscross. So the displacement of the object is given by the formula, the average velocity multiplied by time interval. So the displacement here is, now the next step will be substitution. So the average velocity is given, that is 6.02 meter per second, multiplied by time interval is 137 seconds. So you cancel out this second by this second, we'll cancel out by this second, then we'll be left with, it's better to change colors. So the displacement of the object is this, multiplying these two numbers. You just multiply this and find out the final answer. So the answer is, if you have calculator, you can use calculator. Now, after using multiplying these two numbers using a calculator, you will find the answer, an answer which is 824.74 meter. This is the displacement of, this is her displacement, that's Andra's displacement. Now let's move on to the second example. Simpson drives his car with an average velocity of 48 km per hour to the east. How long will it take him to drive 144 km on a state highway? So as now here what I have to just pick out the given quantities. What are the given quantities? So Simpson's average velocity is, that his average velocity is 48 km per hour, and the total displacement is 144 km. We are asked to find what is required is how long. Don't forget that whenever you are asked to find the term how long, it means you are asked to find time. Okay? How long is time, how fast is speed, and how far is displacement or distance. These are common terms in physics. So whenever you are asked to find like time, we are asked to find how long the object is moving, how fast means the speed, and how far is the displacement of the object. Like we are asked to find time interval. Then solution. It's better to change color. So once we pick out the given quantities, the next step is just writing the formula. The average velocity is given by the total displacement divided by time interval. So we just crisscross this and make time interval the subject of the formula. So average velocity multiplied by the time interval is equal to the displacement of the object. So to find time interval, we divide both sides by the average velocity. So once we make the time interval the subject of the formula, the next will be matter of substitution. So this is, the displacement is 144 km divided by 48 km per hour. And the final answer will be, using calculator, try to divide this and you will get 3 hours. That is the final answer. So if Simpson is driving at a speed of 48 km per hour, he needs 3 hours to cover 144 km distance. Now let's solve the third example. A bus travels 280 kilometers south along a straight path with an average velocity of 88 kilometers per hour. The bus stops for 24 minutes, then it travels 210 kilometers south with an average velocity of 75 kilometers per hour. So how long does the total trip last? So we are asked to find the total time taken for the whole trip. So here we have 3 cases. Then it will be better to prepare a table. We have S1, like let's find the displacement 1, let's say. What's the displacement 1? We have 3 cases. Displacement 1, 280 kilometers. Displacement 2, that is when it is at rest, and we have here a bus, the corresponding average velocity, average VAV1, which is 88 kilometer per hour, and what's VAV2? It is 0 because it's at rest. The bus stops, and here we want to find delta T1, delta T2. The bus stops for 24 minutes. We don't know the time interval, the time taken to cover these 280 kilometers. We want to find, we'll find that. And the third case is displacement 3 is 210 kilometers. And average VAV3 is 75 kilometers per hour, and delta 3 we don't know, we won't find this one. Now we want to find the time taken to cover the first trip. This is the first trip, the second, third phase. We divide this in 3 cases. These are the 3 cases. First case, second case, when traveling the first trip, when it stops, this is the third trip. So here we want to find delta T1 and delta T2. So we know that delta T1 is the same as, we know that average velocity is defined as the ratio of displacement to change in time. We know this formula. Now, making time interval the subject of the formula, time interval is given by change in displacement divided by the average velocity. This is a formula. So delta T1 is the displacement 1 divided by the average velocity 1, which is given by delta X1 is 280 kilometers divided by 88 kilometers per hour. So this is the same as, you can use calculator, you just divide these 2 numbers, 280 divided by 88, then you will get 3 point, approximately to 2 significant figures, you will get here 3.18 hour. Let's find the same way, let's find delta T3, which is the displacement 3 divided by average velocity 3, which is the same as, the total displacement is 210 kilometers divided by 75 kilometers per hour. This is the same as, use calculator and divide 210 by 75. We'll get 2.8 hour. Now let's come to our question now. So we know that the total time, how long means T, we want to find the total time for the whole trip from the very beginning until the end. So total time is T total is equal to 3.18 hour plus, here this is very important, we have to change this to, because these two units are in hours, so we have to convert this to hour. So we know that 1 hour is the same as 60 minutes. So to convert 24 minutes into hour, we divide by 60. 24 divided by 60, which is equal to 0.4 hour. This is the same as 0.4 hour. So 3.18 hour plus 0.4 hour plus 2.8 hour. So when you add all this using calculator, 0.4 plus 2.8 plus 3.18, this is equal to, you will get 6.38 hours. This is the total time taken to cover the whole distance, or the time taken to last the trip, the total trip. This is A. This is the answer for question A. Let's come to question B. How do you solve B? B, what is the average velocity for the total trip? Just use the formula. We know that average velocity is defined as the total distance or total displacement divided by time interval. And the total displacement is, we add all the distances, add all this. The total displacement is 280 plus 0 plus 210. We add all this. That's total displacement. So the first case, the bus covers 280 kilometers, it stops for 0.4 hour and travel another distance 210 kilometers. So the total distance traveled is 280 plus 210, which is 490 kilometers, divide by, and the total time is 6.38 hour. When you divide these two, you will get, take calculator and divide 490 by 6.38, which is the same as 76.8 kilometers per hour. This is the average velocity of the bus. But some students, they try to calculate, take the average velocity of these three. They get confused. But if you try to calculate the average velocity using this formula, when you add this, that's 88 plus 0 plus 75 divide by 3. Let's see what you will get. Let's use calculator, add these two numbers, 88 plus 75, and divide the answer by 3. You will get 54. This you will get 54.3, which is completely different from this answer. So whenever you are calculating the average velocity of the object, what we need is the total displacement divided by total time. This is how you calculate the average. This is very important. That's how you calculate the average velocity of the object. That's all what we have for today.